Welcome back, everybody, to our lecture on parsing. And let's make a toast on our first monad. That's great. And now we can move on. And let's look at another operator on parsers that really makes it into a monad, and that is namely sequencing of parsers. So what we want to do is we want to take a parser and not kind of, try the other one if the first one fails, but we want to kind of sequentially compose them. So we want to kind of run one parser, and then when it's terminated, we want to run the next parser. And for that, we're going to use the so-called do syntax. And the do syntax, that's one of the advantages of having a monad, because now you can write code that looks, that makes this sequential composition clear. So here's what we want to write. So we want to write the following. We want to say, try to parse an item, call that X. Parse another item. I don't care about that one, so I don't give it a name. Then parse a third item, call that Y, and then return the pair of X, Y. Okay? So what you see here is that we're sequencing these three parsers of items, and we're just returning the first and the last. Now, if you look at this code here, remember that we talked about the layout rule. So all these things here must be lined up really nice. You can also put curly braces and semicolons in here. That's actually what I usually do when I use the do notation, because then it looks even more like imperative code. And as we already showed, if you don't put this kind of left arrow in there, then the parser is called, but the result is discarded. All right. So the other thing is that when we are composing parsers, multiple parsers in a row, what we want to have is that when any of them fails, the whole thing will fail. And then we can always kind of try with the triple plus to use another parser. So if we parse, parse here P, that was our example here, it would take this guy and parses three characters and returns the first and the third. So it returns this. But if we try to apply that to a string that only has two characters, then it won't work. So it will fail. It will fail. You see it here, failing. There, I'm failing, like the parser. Okay? So when a parser, any parser that you sequentially compose fails, you want the whole thing to fail. Okay? And the other thing is that the real advantage of having a monad is not that it makes you look smart. It's not that you're a cool kid. It's not that you can write the millionth blog post on explaining monads. The real advantage of monads is that you can use the do notation. All right? So that's all there is to it. Not a big deal. All right, so let's continue writing some more parsers. And here in this case, assuming that we have this parser that can do sequential composition, we're going to write the following function that takes a predicate from character to bool and returns a parser for characters. So here it is. Set of P, so we're looking for a character that satisfies P. We parse an item that will return X. If P holds, then we immediately return X, and we don't change the input. If P of X does not hold, then we have to fail. All right? So this is quite obvious. we try to parse any item, then we check whether the predicate holds. If it holds, we use the parser that always succeeds. And if the predicate does not hold, we use the parser that always fails. So those came in quite handy, huh? All right, let's use this parser now to write some interesting things. So say that we want to parse a digit. Well, what we can do is we can say, use this set with isDigit. So now this thing will try to parse a character, check whether it's a digit. In that case, it will immediately succeed with that digit. If it's not a digit, it will fail immediately. If we want to parse a specific character, like here, so it's character X, then we can use sectioning to create a predicate, X equals equals. So this is a function that expects a character and checks whether it's equal to X, and then we apply that to set. All right? So here you see a quite nice use of sectioning. In case you wondered, why on earth is this weird sectioning in Haskell? Well, here you have an example of this. Now, some people say, but you know, there's an X here, and there's an X there. I can write this point-free style. So maybe you should try that. You can write this thing here in point-free style. But again, as I warned you, when you use point-free style with function composition and so on, your code might become quite unreadable very quickly. But in this case, I think it's a nice challenge to write this one point-free. It will look quite nice. Okay. Let's look at the next one here. This is a parser that tries to parse P 0 or more times. And you see this often. It's like a regular expression or a repetition. And I want to find, 0 or more digits. Or if I want to parse an identifier, I want to parse a letter followed by 0 or more identifiers or digits. So, this often happens when you're trying to parse things. So here we see many takes a parser of A and returns a parser of list of A. And guess what? This is defined recursively. So many of P first tries to parse at least one P, and if that fails, it returns the empty list. And, it would be slightly nicer to use the parser that always fails there. Now, how do we write many1? Well, we define that in terms of many. So we have here a mutual recursive definition. So if I want to parse P 1 or more times, I try to parse P once. I get the value V. Then I try to parse 0 or more times P. I get the value. This can be the empty list if I return the empty list. So that I have to apologize. This is really returning the empty list. That's not failing, because if I parse P 0 or more times, I can parse it 1 times or 0 times. And in the 0 times, I have to return the empty list. So, that was something there. So if we parse it there, so we get 0 or more times, and then we return V concatenated with V. So this is the 1 times, and this is the many times. Good. You see? So this is like a subtle mutual recursion, and very subtle. Like even Eric made a mistake there. So you better pay attention. Okay, the last thing here is we're going to use a function, define a function that tries to parse a string. So far we have seen many examples where we're trying to parse a character, but I want to parse a string. So if I want to, and remember, strings are just lists of characters. So if I start with the empty list, well, I just return the empty list, the empty string. If I try to parse the character X cons X's, well, I try to parse the character X. I recursively try to parse a string that represents the rest of this thing. and then I return the result. Well, I found an X, so I return that, and I return that, so I just return the string. So this just checks whether this string is the prefix of my input. Good. So now we can define a parser that consumes a list of one or more digits from a string. So this is starting to become more like, parsing an actual language. So what we do is we want to parse a list, so we have to parse an open brace and a closed brace. We're not interested in those values, so you don't see a left arrow there. Then we're trying to parse a digit, and then we're trying to parse many characters, comma, digits. Okay, because we want to have a list of one or more digits. So there's one digit, and then the more digits here, and then we just concatenate that digits with the other digits. So here you see how we can take all these elementary parsers and combine them together to write already pretty complicated parsers like this. If we apply this parser here on the list, it's a string, but we want to parse that string as a list, we will see that we get the digits 1, 2, 3, 4. And if we're trying to parse it on something that has, that's not a proper list, we will get an error. Okay? Now, of course, as we said, this is a super simple parser. If you want to write a real parser, or if you want to, use a parser in real code, you typically want to do something smarter when there are errors than just, returning the empty list. At least you want to kind of, give the position in the input list where things go wrong. Or you want to try to correct errors or whatever. But again, we're trying to cover here the very, very basics of parsing. And there's plenty of parsing libraries for Haskell and for other languages that are based on the same idea that add all these more sophisticated features. And thank you very much, and see you in the next part.